In accordance with Haskell's Code of Safe Practices, any excavation deeper than 4 feet should either be sloped, benched, or shored. The following presentation represents safe practices for sloping excavations greater than 4 feet in depth. To ensure safety, an excavation inspection must be performed by a competent person at the start of each workday or following any major weather event. A competent person is someone who, through training or experience, is knowledgeable concerning OSHA Code of Safe Practice for a worksite. This person is given authority and responsibility to correct hazards to protect workers. Trenching work by nature involves moving large amounts of soil. These large amounts of soil can in themselves be dangerous. A cubic yard of soil can weigh more than 3,000 pounds. Many excavators can easily lift more than a cubic yard of soil in a single bucketful. Therefore, caution should always be used when moving large amounts of soil. Inside an excavation, many potential dangers exist. In trenches with slides that are too steep for the soil type, there is also a danger of cave-in or collapse. Being buried up to the waist can also be fatal because it can cause crushing injuries that prevent breathing. Even collapses that are knee-deep can cause fatal injuries or medical complications such as septic shock. In each of these situations, rescue is often delayed by the unsafe conditions which led to the collapse. Poor air quality is another danger of working in excavations. In some areas, the ground will naturally emit dangerous gases which can gather at the bottom of a trench. Since different gases weigh differently, they may gather at certain depths within an excavation. Many dangerous gases are invisible and odorless. If exposed, many gases will cause unconsciousness and can eventually lead to death. If a person becomes unconscious while in an excavation, it can be difficult for rescuers to reach the person without exposing themselves to the danger. Never enter an excavation of unknown air quality. Since conditions will change over time, regular testing is essential. Being able to get in and out of an excavation quickly is essential to maintain safety. At any time, workers should not be farther than 25 feet from an exit to the trench. In the event of an accident, being able to exit an excavation quickly can be critical to safety. Ladders should extend 3 feet above the top edge of an excavation. Any trench deeper than 4 feet must be sloped. The proper slope of a trench's walls depend on soil type and depth of the excavation. There are many kinds of soil, and each will fit into a category based on its hardness. A-type soils are the sturdiest and require the least amount of sloping. The ratio of rise over run for type A soils is 3/4 to 1. B-type soils are weaker and require shallower slopes. The ratio of rise over run for type B soils is 1 to 1. C-type soils are the weakest and most prone to collapse. The ratio of rise over run for type C soils is 1.5 to 1. Unless an excavation site has been certified by an engineer, it is safest to assume that all soil is type C. The slope of a trench wall can be difficult to measure. However, there is a simple formula which can be used to determine if a trench is safe, even in the weakest or type C soils. The first measurement that is needed is the width of the bottom of the trench. The second measure that is needed is the depth of the trench. The last measure is the width of the trench at the top of the trench. If 3 times the depth plus the width of the bottom is less than the width of the top, the trench is properly sloped. In some situations, proper sloping is not possible. This may be due to obstacles such as roads or power lines. In these situations, a trench box may be used. A trench box is a metal enclosure that reinforces the walls of a trench. When placed in an excavation, a trench box must have equal support on each side to prevent tipping. When using a trench box, it is necessary to leave 18 inches above the top of the excavation. These measures are to help ensure that items on the ground do not fall into the trench box. Soil not supported by the trench box has the potential to cave in. Inside the trench box, the excavation cannot extend more than 2 feet below the bottom edge of the trench box. Workers should never leave the confines of a trench box while in the excavation. No worker can be in a trench box that has a suspended load hanging over it. In this situation, all workers must either exit the excavation or move to an adjacent trench box. This section will demonstrate the proper use and implementation of rigging and material handling. Remember, a qualified rigger must be in attendance for any hoisting activity, either assembly or disassembly work to begin. A standard choker hitch involves looping a single cable around the load and connecting it with itself before connecting with the crane. This method allows the load's own weight to tighten the cable and hold it securely. The hooks used for this method put quite a lot of strain on the end of cables. Remember to inspect the lines carefully before each use. A basket sling is a simple type of rigging method where the cables run down and back up, passing around the load. When the load is unstable, such as made of many pipes, an extra loop wrapping around the load may be added to help further secure the load. When a cable is lifting a load vertically, the cable is near the rated and tested capacity on its tag. However, when the cable is stressed at an angle, the cable bears a greater burden than if it were vertical. Imagine a scenario where you hold two weights down at your sides. Your arms are like the legs of cables, while the weights are like the supported load. When you hold the weights at your side, it may seem rather easy to handle. But when you try to extend the weights out, the forces seem much heavier. The larger the angle from vertical, the more stress that is placed on each arm, and likewise each leg of cable. At vertical, the cable's true capacity is equal to the capacity on the tag. At near 30 degrees, the cable is reduced to 87% of the tag's reported capacity. At near 60 degrees, the cable is reduced to 50% of the tag's reported capacity. At near 90 degrees, all of the tag's reported capacity is lost. The vertical hitch. This type of rigging method involves the load having various anchor points embedded directly into the load, with connecting cables straight from the anchors to the crane. There can be any number of connection points with many different configurations based on the specific load at hand. This example shows what's called a four-leg connection. With use, cables become worn and may be hazardous to the worker if not properly checked and repaired when needed. This is an example of what's called a bird cage. The cable has become untwisted and must be repaired or replaced. When cables are bent to extreme angles, the line may become kinked. These kinks drastically reduce the cable's capacity. Whenever a cable receives stress, it's possible that the small wires that make up the cable may break or fray. No more than 4 strands can be broken in a single lay before they must be discarded. This is an example of a passable cable ready for use. Remember to check the attached tag to find our specific details, such as load capacity, condition, etc. If you are ever unsure whether a cable is safe, consult your rigging specialist or supervisor. Before using any equipment on the job site, it's important to first thoroughly check it over, inspecting for any damaged parts and making sure everything is in working order. In the case of the excavator, there are several panels covering the fluid pipes and gauges, the engine compartment, and the filter area. Keeping these clear of debris such as dirt or branches helps guard against malfunction, overheating, and equipment failures. Also outside the cab, the operator should check the mirrors and check the external lights to maintain visibility for both the operator and other workers. Failure to be aware of your surroundings can easily result in injury. Inside the cab, there are several more things to check. The glass should be free of cracks, as weak panels are more likely to break if hit by debris. The seat belt should fasten securely to ensure the safety of the operator, and the backup alarm must be loud and clear so that other workers are always aware of the excavator's movements. The lever beside the seat must also be in working order, as its position indicates whether the excavator can move, and therefore whether it's safe to approach. There are many other things that may need to be checked before the operating of such a machine, and you can find them all in the operator's manual. Because of the potential for injury from malfunctioning equipment, it's important to maintain a daily inspection log and immediately report damaged components for the safety of everyone on the job site.